Alright, so polynomial division. I will say that I've seen this done a few different ways. I've seen like synthetic division and I've seen some long division, and those are pretty typical in your textbooks. I'm going to try to appeal to some other way of doing polynomial division in this video. So it might not be something that you're as used to, depending on where you went to school. So let's just go with an example. We're going to do some polynomial division here. So our example is, if we had the polynomial, let's say f of x, which equals 3x cubed plus 4x squared plus x plus 7, and we were going to say we're going to divide by let's say x squared plus 1. X squared plus 1. Alright, so we're going to try to figure out what that equals and if there's a remainder or not. Alright, so that's what we're going to do. So now let's keep in mind we could write this like this. What we're saying is, what is f of x going to equal when I divide it? So that's going to equal x squared plus 1 times something plus maybe some remainder. And that's connected to what we had just done in the previous video with just plain old numbers. We're taking f of x, and we are in fact dividing by x squared plus 1. And that will equal something, not necessarily that something. I'll put 2 question marks. That'll equal something, but it might not come out evenly, right? It might be like our example with numbers where 30 doesn't get divided by 4 evenly. There's a remainder. So we're going to do the same thing with the polynomial division. And I'm turning it into multiplication because I've got a way of dealing with multiplication that's a little bit easier. So again, if you wanted to do polynomial division like out of your textbook using synthetic division, that's fine. There's plenty of videos online about that. This is a little bit of a different way. Okay, so the first thing I'm going to do is I'm going to start to create a box. I'm going to create a box. And our box is simply there to organize our work. Because what I'm trying to calculate right now is, well, what does x squared have to be multiplied times to get f of x? X squared plus 1. X squared plus 1 is going to go on the side of my box. So there's going to be a 2 by a certain amount of elements or terms over here. So I'm making a 2 by, it might be 3, it might be 4, we have no idea how many terms we will need. So x squared plus 1 times something on the bottom will give me my f of x term. Now I am also going to, over here, write something else out. There's 1, 2, 3, 4 terms here. 3x cubed, I'm going to circle it. 4x squared, I'm going to circle that. X, I'm going to circle this, and 7. I'm trying to get all 4 of these terms to show up in here. X squared plus 1 times something will give me what's inside, and what's inside should combine to give me that. 3x cubed plus 4x squared plus x plus 7. Okay? So as I go through it, I'm writing these out just to remember, hey, I got to make sure I get all of these. That's my goal, is to try to attempt to get that. Now, it might not work evenly, right? It might not be perfect, and I might end up with that remainder. So let's see how far we can get. All right? So if I'm trying to get this first term, 3x cubed, I'm going to start down here. So I want 3x cubed. That's what I want to get. What would I have to multiply x squared times to get 3x cubed? Well, I would have to multiply times 3x, right? 3x times x squared would be a 3x cubed. Okay, and then part of this gets filled out automatically. If this is 3x, then 3x times 1 is 3x. That's here. All right, so we've taken care of this first term. We know we've satisfied it is 3x cubed. We got 4x squared. And I've already got a 3x term, so it gets a little bit messy, but I still need to get this. I can't just skip over that. I need the 4x squared. Okay, so I'm going to put 4x squared here because I need to satisfy that requirement. Alright, so then what would go here? Well, that's x squared, so this would be 4. 4 times x squared is 4x squared, certainly. And 4 times 1 is 4. Okay, so far I've gotten the 3x cubed term. I've gotten the 4x squared term. Now I need the x term. So I look in my boxes and I've already got 3 x's, and if I just need 1 x, I need to get rid of 2 of them to get me just the x. So I'm going to put negative 2x. And I come down here. What times x squared would give me negative 2x? It doesn't work, right? I can't multiply something that's a polynomial, times x squared to give me negative 2x. So this is kind of where we fail. It's not going to work. I shouldn't write an x there. It should be, because that's going to look like an x. Maybe I'll put a question mark. Something times x squared would be, and it doesn't work anymore. So we're starting to realize that what we have is we're going to end up with a remainder, right? Because certainly we've done everything correctly here. What we do know is that we've got f of x, which was that big long polynomial, that is going to be equal to x squared plus 1 times 3x plus 4 plus our remainder. Well, what would our remainder be? What would our remainder be? Well, our remainder is whatever else we would need to complete this polynomial. We still needed x and 7. And now I had 3x, so I had 3x from all of this to create it. So what else I needed was negative 2x. And what else would I need to get 7? I have 4 here, so I would put a 3. And sometimes I write them in the box, even though it doesn't make sense to do that because we don't have anything we can multiply times. But negative 2x plus 3 would have been nice to have, because then that would make this polynomial. So what is our polynomial division? F of x is equal to x squared plus 1 times 3x plus 4 with a remainder of negative 2x plus 3. Okay, so we could write it, yeah, this would be a great way to do it. This is our remainder. This shows up because there is actually something called a remainder theorem. And so there's a way to figure out a remainder when it's slightly more easy than this, and that's what the next video is about finding out what the remainder would be. And so I'm going to go through an example for that.